In the previous videos, we have discussed about the different balance of system components, that is inverter and charge. Inverter we'll discuss now. Previously we have already discussed charge controller and battery. Now let's discuss about two more balance of system components, that is inverters and net meters. Now first talk about the inverters. What is an inverter? An inverter is a device which is used to convert DC current into AC current in a PV system. In a PV system, there are three different configurations of inverters that can be used. The first one is centralized inverters, second one is multi-string inverters, and third one is micro inverters or module integrated inverters, or you may call it as a AC module. We'll discuss these three in detail. Centralized inverters. So several strings of solar panels are connected together in parallel to form a PV array. We know about this, right? So the complete output of an array is converted into AC by means of a single macro inverter called central inverter before that AC is fed to the grid. So the entire DC voltage generated by the PV array will be converted into AC in a single inverter called centralized inverter, right? And these kind of inverters are mostly used in applications such as large arrays installed on buildings, industrial facilities, as well as field installations, right? Around 10 megawatt or 5 to 10 megawatt of energy required generation, we use the centralized inverters. What are the advantages? So low cost per watt, high efficiency, and comparatively very easy to install. Drawbacks are large size and less system reliability. Why there is a less reliability means there is only one inverter. If that inverter is under maintenance, the complete building which depends on this solar power plant will be in darkness. That is, the reliability of power supply is less. You can see one more sketch of this centrally connected power inverter. Different strings are connected in parallel, and when all the output of a DC is connected to AC by means of an inverter, centralized inverter. Next one is multi-string inverters. String inverters means, as we already know, an array consists of number of strings in parallel. So instead of placing a single central level inverter, we'll use one inverter for every string. Say for example, there are 3 strings in an array. We'll use 3 inverters for each and every string. That's why we call it as multi-string inverters. And these string inverters are mostly used in home and commercial solar power systems in the range of 1 megawatt to 3 megawatts. Right. So you can see in the diagram, you can see there is an inverter for each and every string. Say in this diagram there are 2 strings in an array. So for each and every string there is an inverter, and both the inverters are connected again to central level inverter before feeding to the grid. So if there is a problem with the inverter 2, then inverter 1 will function as it is. If there is a problem in inverter 1, then inverter 2 will function as it is. So the reliability of power supply or the design flexibility is increased in this system. Coming to the advantages, as I already told you, allows for a high design flexibility, high efficiency, and robust. The drawbacks are large size and cost is relatively high because of using more number of inverters. You can see in this diagram again, a string is connected to one inverter, and all the inverters finally are connected to grid. It is how the system will work. Multi-string inverters, it is also called branch connected power inverters. The third configuration is micro inverters. The micro inverters is also called AC modules or module integrated inverter systems. That is, in this AC modules, a micro inverter is directly integrated with a PV panel, yielding a straightaway AC. It's nothing but a AC panel. Generally, panel will give DC. Because panel is coupled to inverter, you will get a AC straight away from a panel itself, and straight away you can connect to the grid, and thereby the wiring required for cabling will be less. You can see the diagram. Module plus inverter, integratedly you will get as micro inverters. These will be used for very less wattage applications like 500 kilowatt to 1 megawatt. Advantages is panel level MPPT is possible in this case. Higher increased reliability. Right, if any single module is damaged, then that module alone will be left alone, and the remaining entire system will work out. High design flexibility. Right. So drawbacks are higher cost, increased maintenance, and increased complexity in installation. This individually connected power inverters you can see in the figure. A module and a inverter. Likewise, everything will be connected to the grid. It is how this system will work. It is all about the inverters. The last balance of system component is net power meters. This net metering, also known as net energy metering, is a solar incentive that allows you to store energy in the electric grid. Confused? So let's discuss about this in detail. With net metering, excess electricity is fed into your electricity utility grid when your system is producing more than you need. When this happens, your meter actually runs in reverse direction. You require 100 kilowatt hours, but your array connected, which is kept in your building, producing 150 kilowatt hours. So you will use 100 kilowatt hours. That 50 kilowatt hours will be sent to the grid during the morning time, and again during the night time you require 50 kilowatt hours. That time solar energy will not generate anything, or you require 70 kilowatt hours, and the solar energy will not generate anything. Now you will take that 70 kilowatt hours from the grid. Right. Now what happens? You are giving 50 to the grid and you are taking 70 from the grid, and for that, at the end of the month you need to pay the bill for only 20 units. 70 minus 50, 20 kilowatt hour is 20 units only. You need to pay the bill. That is it. Now let's discuss this in detail. So you have a building on which you have a renewable energy. It is a solar PV system which can generate you the electricity, DC electricity. Now by using an inverter you are converting it into AC, and that AC, now you are getting the number of that is called a generate. Now the next thing is a generating meter. That is the number of units generated. As I already told you, A is 100. The building require 100 kilowatt hour, right? And the panels are generating 150 kilowatt hour. That is A is 100 and B is 50. So total number of units generated by the solar panel is 150. 100 plus 50. That A 100 will be supplied to the building and 50 will be sent to the grid. Will be sent to the power grid. It is during the morning time whenever sunlight is available. Whenever sunlight is not available, your panel will not generate the energy. You need to take the energy from the grid. C is the amount of energy that you will take it from the grid. And total amount of energy that the building require, morning is A and evening is C. Right, A plus C. Net metered consumption is you are feeding B number of units into the grid through a meter called net meter or utility meter. You are using an energy meter only, special type of energy meter called net meter, and you are taking C units of electrical energy from the grid during the night. So net meter consumption is C minus B. That is, you have feed in 50 units and you have taken 70 units. Then 70 minus 50 will be 20 units. At the end of the month you need to pay for only 20 units. Or one more example, you are feeding 100 units and you are taking 70 units only. So 70 minus 100 will be minus 30. That is, the government will pay you the cost of 30 units at the end of the month, because government cannot pay directly to you. It will compensate the bill in the next month. It is how the system will work, which is called net metering system. With this we have completed the components in a solar PV system. The major component is a PV arrays, and the balance of system components are charge controller, battery, inverter and net metering. In the next class or in the next video, we'll talk about the different types of solar power plants. Thank you.